Hi guys, welcome to Placements Ready. In this video, we will be solving the problem rotten oranges from Geeks for Geeks. So basically, we are given a grid of size n cross m where each cell in the grid can have values 0, 1 or 2. Okay, let's see what the value 0, 1, 2 means. So 0 means a empty cell, 1 cell means have fresh oranges, and 2 means the cell have rotten oranges. Okay, so we have to determine what is the minimum time required to rot all oranges, and it is given that a rotten orange can rot other oranges at index I minus 1 comma j, I plus 1 comma j, I comma j minus 1 and I comma j plus 1. Basically, a index, if a rotten orange is there at index ij, it can rot a orange up, down, left and right in 1 unit of times. Okay, so we are given the sample input as 0, 1, 2, uh, 0, 1, 2 and 2, 1, 1. So let's see what is the problem. Okay, so we are given that the grid contains 0, 1, 2, then again 0, 1, 2 and then 2, 1, 1, right? So this can rot this orange in 1 unit of time, this can rot this orange in 1 unit of time, and this can rot this orange in 1 unit of time. Similarly, this orange can rot this orange in 1 unit of time. So basically the minimum time required to rot all oranges is 1, right? So I hope the problem is now clear. Now what we will do in this problem, we need the minimum time, right? So in order to achieve that, we require a priority queue, right? And let's see what data are mandatory in order to solve this problem. So basically we are given a grid, so the row position is at I and the column position can be calculated by j, right? Then we can have uh, ij and we can have the time, right? So we require basically three things in order to have this. Okay, so now what we can do, we can create a node which will be containing the values time, x and y, and we can create a priority queue of type node, vector of node. Because we require a mean priority queue here, then we require a comparator, so it can be written as creator node pq. Okay, so I hope that is making sense. Now in order to solve a problem of bfs and dfs, we require a visited array. Why? So that we don't do the same work again and again, right? So we require a visited, and now we need to explore all the four directions. So basically if you are at I comma j, you need to explore the upper direction, so which is I minus 1 comma j. Then you need to explore the left direction, which is I comma j minus 1. You need to explore the right direction, which is I comma j plus 1, and the down direction, which is I plus 1 comma j, right? So this can be achieved using a dx dy array. So how can we define this dx array, right? So if you carefully observe, like for left, the change in x is 0, so dx array can be written as 0. Now for right, again the change is 0. Now for top, the change in x is minus 1, and for down, the change in x is 1, right? Similarly, you can have a dy array. So for left, the dy is minus 1, for right, the dy is plus 1, and for down and for upper, the dy is plus 1, like 0. Okay, so we can use this. And now, first of all, what we need to do, we need to push this rotten oranges into the priority queue, and initially they will have a time of 0, right? So all this will be pushed. So let's see, this 2 is pushed and the time is 0, so it is at, let me number the row number and column number. Okay, so now this will be pushed, so this 2 is present at 0 comma 2, right? And the time is 0. So first of all we will write the time so that we don't have to worry about the comparator, right? So this will be pushed into the priority queue. Now this will be pushed, so the position is 1 comma 2 and the timing is 0. So 1 comma 2 and time is 0, and then again this is at 2 comma 0 and the timing is again 0. So time is 0 and it is at 2 comma 0. Now first of all this will be popped out 0 comma 0 comma 2, and we will explore the 4 directions. So this will be explored with the help of this, right? So now add like when you push it, you also mark it as visited, right? And visited will be of the same size as the grid, that is of size n cross m. So this will be visited, this will be visited, and this will be visited. So this will try to visit this. So this is at position 0 comma 1 and the timing will be now 1, right? So 1 is the timing and it is at the position 0 comma 1. Now in the second time 0 comma 1 comma 2 will come out. So 0 comma 1 comma 2. Okay, so basically this will come out and this will try to explore this and this will try to explore this, and both of them will be pushed. So let me rub this for your understanding. So this will be pushed and this will be pushed. So now was having time 0 and this will be having time 1 and this will be having time 1. So the position of this is, now the timing is 1 and position is 1 comma 1, and again the lower uh, orange, which is this, so its position is 2 comma 2 and timing is 1 again. So position is 2 comma 2. Okay, now next time this will come out. So 0 comma 2 comma 0 will come out. So this will come out, and now this has been, as soon as you push, you mark it as visited. So this is visited, this is visited, so it will not do anything, right? So this will not do anything. Now this will come out 1 comma 1 comma 1. So this, and now this will try to visit this, right? But again, if you see, before that this would have come out and this would have marked it as visited, and that would have time taken 1, right? So you can carefully observe here, like all the 3 oranges basically take a time 1, right? So if I rub it and draw it again, so let me explain you. So 0 comma 1 comma 2, 0 comma 1 comma 2, and 2 comma 1 comma 1. So this rotten orange will rot this orange in 1 unit of time. This will rot this orange and this orange in 1 unit of time, and this rotten orange will rot this orange in 1 unit of time, right? So I hope you have got the idea in order to solve this problem. Now let me explain you the code. So basically here I have defined the node as pair of int comma pair of int, right? In order to store the timing and in order to store the x and y. Now I have declared a dx array, right? And now I have declared the dy array, right? Now let's take a priority queue of type node, and basically we have to find the minimum timing. So we are taking a minimum priority queue here, right? Now n is the grid dot size and m is the length of column. Now we have created a visited grid of size n cross m, and initially all the elements are not visited. Now we will try to iterate on the 2D grid and we will check which oranges are rotten, right? Now we will push all the rotten oranges into priority queue and make them visited as well. So that is done. Now my initial answer is 0. Now we will do the operation as long as the priority queue is not empty. So first of all we will take out the element from the priority queue top and we will pop it. Now x will be equal to current dot second dot first, means our pair was of type int comma pair of int. So current dot second will give you the pair and first will give you x. Now y will come out by using dot second and the timing is current dot first, right? And we will update our answer to maximum of answer comma t, right? And now we will try to have a new x which is equal to x plus dx of k and new y which is equal to y plus dy of k. Okay, now we will check if it is safe to visit that grid. Now let's see what is safe function. So is safe basically returns that whether the new x is in the range of the grid. So x should be greater than equal to 0. Similarly y should be inside the grid. So y should be greater than equal to 0 and x should be less than n and y should be less than n, right? Now it should not be visited, and it if it is a fresh orange then only we require to push it, right? So that's why grid of xy equal to 1. So in that case we will push that, and now the timing will be basically whatever was the previous timing, t plus 1, right? And this will be visited, and we will mark the grid as that it has been rotten. So we update that to 2. Now we will check if all the elements have been visited or not, or basically if all the rotten oranges have been, like fresh oranges have been rotten or not. And if it is not the case, if we find that any of the rotten orange, like fresh orange is not rotten, we will simply return -1, right? And finally we can return our answer. So in this way you can solve this question. And talking about the time and space complexity for this, so we are requiring a space of n cross m here for grid, and also the priority queue is there. So priority queue in worst case will require a time of uh, let's say we discuss the space, so it is like this. So let's say all the oranges are rotten, so in max priority queue will be having a size of n cross m, and the timing for this will be, you are requiring a first loop for in order to visit all the elements, so that will be requiring a n cross m time, plus if let's say all the oranges are rotten, so n cross m into log of n cross m for pushing it into the priority queue. And now you are iterating again on the priority queue for each of the n oranges, and you are trying to explore all the 4 directions. So this will be the overall time complexity. So I hope the logic and the problem as well as the time and space complexity is clear for the problem. So for your reference, I will attach the problem link in the description. You can check it out, and if you haven't subscribed our channel, please subscribe and like this video and share among your friends. Okay, and if you have any doubt, you can comment it in the video, and please like this video and subscribe to our channel.